So I'm running through, as it says here, homework 2, number 16. So this is one version of it. So your version might not be exactly the same, but you should get an idea from this. This will also illustrate the point of when you're doing composite functions, you have to consider the effects to the domain. So we're doing this. In the problem, it says G composite F like this, but those two notations mean the same thing. So the idea of this is, first of all, you would take the outside function, which is G, 1 over something minus 2. Then you insert in the big gaping hole the F, because this says you're supposed to put the F function inside of the G function. So then I'd put 1 over x minus 3 right here. And then we have to begin simplifying this. So this would be 1 over, and to simplify this, you'd have to add the two fractions on the bottom. So I'd have 1 over x minus 3 minus 2 times x minus 3 over x minus 3. Got to get a common denominator in order to add those two fractions together. So the next step would be 1 over x minus 3 minus 2x minus 6 all over x minus 3. And then we combine those together, we get 1 over, of course, that would be a negative 2x, and a negative 6, that would be 1 plus 6, which would be plus 7, all over x minus 3. Now when you have a number divided by a fraction, you just flip the fraction over and multiply. So this becomes x minus 3 over negative 2x plus 7. So that would be the function g of f of x. But one thing, and this is one of the reasons I did this problem, I wanted to point out that notice that the original function f of x is undefined at 3. 3 is not a part of the domain. And so notice down here that it's okay to plug into 3. But that's a problem because this function was created by using f and g. So since f is not defined at x equals 3, we may have to make a little comment here that say, by the way, x cannot be equal to 3. Because the problem, this 1 over x minus 3, gets lost in the algebra and it's no longer a problem. So we have to make a note to let people know that it's still a problem. So the actual domain of this would be, now notice you look at this, there's also a problem when x is equal to, what would that be, 7 halves? 7 halves is also a problem. Because you can see that it makes a problem. The x equals 3, it does not show up in the final answer. That's why we have to make note of it. So although in homework 16, the problem number 16, it asks you to write the function, and it also asks you to give the domain. So the domain would be from negative infinity to 3, and then from 3 to 7 halves, and then from 7 halves to infinity. So this is something you have to look for anytime you put a function inside. So the composite functions, right? Where you have in this case you have f inside of g. If the inside function has a limit to its domain and it doesn't show up in the final answer, aka this spot right here, then you have to make note of it as kind of a side note, as a part of the definition of the function.